We're going to look at data that is represented by the normal distribution. Now, the mean we use the symbol mu for, Greek letter M for mean, instead of when we had discrete data, we called the mean x bar. So we've just swapped our notation from x bar to mu. The standard deviation we use is sigma, which we've met before when we were using the calculator. Now, the normal distribution is symmetric, and we represent it in what's known as the bell curve. So the middle of the data is the mean, and we've got the same amount of data above the mean as we have below the mean. So the probability that we lie somewhere within this data is 1. You must have a value somewhere. But the symmetry means that the probability you are above the mean is 0.5. The probability you're below the mean is also 0.5. Now, the curve isn't just a random curve, it has some very specific properties. One of these being that if we start from the mean and we go 1 standard deviation above the mean and 1 standard deviation below the mean, 68% of the data will be in this region. Now that then means if we want to know how much is, say, below 1 standard deviation, this area is 34%. This area is half the diagram, is 50%. So the probability that any point is less than the mean plus the standard deviation is always 84%. And that's a fixed situation. And 95% lies within 2 standard deviations. So there's 1 standard deviation. There's a second standard deviation. So this middle area is 95%. So that means if we just wanted to take below 2 standard deviations above the mean, this area is half of the 95, so is 47.5. This is obviously 50%, so the probability that we're 2 standard deviations below the mean, above the mean, is 0.975. And we can work out all the other little areas as we go along. But those are key facts to learn. If it's any other value, then on the Casio calculator we're going to use number 7 and normal CD, which is number 2. And our lower and upper values, we tend to work with negative 1,000 and positive 1,000. We'll get to those when we do an example. So here we've got some data. We know it's normally distributed because of this letter N. The first number in the brackets is the mean, and the second number in the brackets is the variance, which is the same as the square of the standard deviation. We just have to be slightly careful because the calculator always wants just the standard deviation, not the value squared. So if we were going to ask the calculator for this piece of information, we need to put in that the lower is going to be down at negative 1,000. The upper will be at 33, because we're going from 33 downwards. Sigma, the standard deviation is 4, we ignore the square sign, and mu, the mean, is 30. And the calculator then tells us that that answer is 0.773. If we think about our bell curve, so we knew that the mean was at 30, and we're being asked about what's the probability it's less than 33, so what proportion of this diagram is below 33. So it must be more than 50%. The standard deviation is 4, so 34 is the mean plus 1 standard deviation, which we said that's going to be 84%, so somewhere between 84% of the diagram and 50% of the diagram. So our answer of 77% is looking quite good. With normal, because it's a continuous distribution, it doesn't matter whether it's strictly less than or whether it's got an equals to, it doesn't make any difference. So if we want to know for the same distribution, what's the probability it's greater than or equal to 24, we have a lower value of the 24 and an upper value of positive 1,000. The standard deviation and the mean are still the same, and the calculator tells us it's 0.933. Does that make sense with what we know about the diagram? There's 30, there's 24. Well, one standard deviation below would be 26. So we know there's 84% above 26, so it's got to be more than that. So 93% makes sense. It's not quite as far as 2 standard deviations away. 2 standard deviations away would be 22, and that would be our 97.5%. If you want to work out more difficult regions, the calculator can just sort it out. So we put in a lower of 33.5 and an upper of 38.2, and the calculator just works out what that area would be. If we've got to do 2 separate areas, so in this one we're being asked for below 27 and above 32, we could calculate those 2 separately, or a cleverer way to do it is to say this is 1 minus the bit in the middle. Because that value the calculator can work out in one step. So 27 to 32 has a probability of 0.464. So that's the probability in the middle, so the probability at the ends, store that into A, 1 minus that answer is 0.535. Putting this into a word context, so we know we've got a normal distribution with a mean of 100 and a standard deviation of 15. Adults scoring more than 140 are genius. Find the probability that we've got a genius, so the probability that they've got more than 140. So we've got all the information. Menu 7, normal. So 140 is our bottom end, up to 1,000. Sigma is 15, mu is 100, And the calculator tells me it's quite rare. 3.83 times 10 to the negative 3. I'm going to store that in A. Now, part B, we're swapping to having a binomial, because now we've got 20 people doing the test and we want to see if they're genius. So we've got this genius probability, which is why I stored it, and we want to know that 2 or more, I should say y, are genius. We're on to binomial now. We can't do greater than with binomial, so we need to rewrite this as less than. There we go, menu 7 down to binomial CD. We're checking number 1 against 20 people. A probability that I kept from before, I'd stored in A, as 3.8 times 10 to the minus 3. So it's 1 minus store that 1 minus that answer. Pretty rare that we're going to get 2 genius out of a group of 20.